Hello, this is Steve Cavanaugh, and I'm excited to give my presentation. The title of the presentation in my research is LiDAR, Enhanced Drone System for Biogas Volume Estimation, and a Solution for Anaerobic Digester Optimization. I am, as a part of my research, surveying 4567, positioning with GNSS. And the presentation today is going to explain biogas, how that moves from biogas to renewable natural gas, a little bit about that process. I'm going to discuss the current GNSS technology for methane leak reduction or detection. And also, I'm going to propose adapting the technology with LiDAR for volume estimation. So kind of walking through this a bit, I'll move to this slide to help us understand biogas. This is a dairy farm in Florida, and very unique way of handling manures now, of where you can actually transfer that manure to an anaerobic digester. We have two of those. We have a concrete digester, a vessel with supplemental heat, and also a secondary digester. This is actually one of my engineering firm's projects, an ambient in-ground digester with a HDPE cover. From there, that is where biogas is generated, and then it is sent to a gas upgrading system. So this process is very unique and emerging, I would say, across the United States and around the world relative to the capturing of methane and converting that to renewable natural gas. A little bit more of the background and sort of getting into why this is an important and relative topic. This is an ambient in-ground anaerobic digester. This one happens to be from Kenansville, North Carolina, from a swine facility. But again, sort of showing the shape and how gas is trapped up underneath that cover when that bacteria breaks down the waste and actually methane or biogas is actually emitted. Following along from there, a close-up of the gas processing unit of where the biogas is refined. It actually comes into a conditioning type of a unit. This is an inlet compressor that's here, and then into pressure swing absorption for separating out the methane from CO2, nitrogen, oxygen, et cetera, that can't go into the pipeline. So a big challenge that happens with this is the actual leaking of methane from the cover. And I've got a couple of shots here from Sniffer Robotics that shows areas of these covers where there can be hotspots or leakage that occurs along the outside of the cover. And interesting, we have been trying to get our hands around this leakage and found Sniffer Robotics, which is one of many, which uses drone technology guided by GNSS and the flight pattern to actually use a thermal imaging, a thermal camera, and other technology, infrared and methane cameras that actually can look at and identify the hot spots in the actual lagoon itself, the actual digester itself. You can see the flight pattern at which the drone flies, and again, very common relative to the technology and the implementation of the technology of GNSS and guiding that drone. And then, of course, being able to map that flight plan, very detailed centimeter accuracy as needed. One of the things that is a challenge, however, is in that biogas, not only the methane that actually is escaping, but also understanding what is the volume, how much gas do we physically have underneath the cover. And so you can see the cover here, and as this gas continues to build and the cover expands, it's important to understand that volume to be able to pace the facility. Also being able to manage the rainwater associated with that and properly setting up equipment for throughput. So having a volume of gas that's fairly accurate, it would go a long way. And that's where really we think about, can we utilize our GPS technology, GNSS, and also equip it with LiDAR. We're already making a run for looking at the methane that's escaping. Can we now, in that same flight pattern where we are equipping it with thermal imaging and sniffing type technology, can we also take LiDAR imaging and be able to actually do surface modeling, where we can take the cover and be able to integrate that to a flat plane and then be able to do really the surface modeling associated with that, creating the volume from the two surfaces. So this could be also something that the farm themselves, as GPS equipment, has actually come down in cost and up in accuracy, and fairly straightforward now with some of the corrections that are happening, of where the farmer itself may see the value of doing this and getting a routine of where they're monitoring through cold season, warm seasons. Incidentally, there's more biogas produced during warmer times of the year, and so that would allow for some staging of that equipment and pacing it through. So that really is the idea of how we can potentially integrate LiDAR in with that methane. Of course, the volume calculations, similar to what we'd be doing of digital terrain modeling and being able to map the base surface, and then through the LiDAR being able to have that flow net, if you will, or that map of those elevations to then be able to calculate that volume. So that's the main issue. And I will also say that it's important too, if you see back to this image, I'm purposely showing the image of the flare. So this is a perfect example of where we have molecules that are being wasted to where it's outpacing the volume of gas that needs to be processed versus what the actual the upgrading system can handle is in excess. And so we're actually having to flare some of that gas. So this would be a comprehensive solution to be able to add LiDAR to that existing drone technology that's being used. And so kind of a simple adaptation of a current GNSS drone operation. I think there's significant market potential based on the number of digesters that are out there. There are swine, I'm showing dairy, poultry, also food waste digesters, and I think this will continue to be a key opportunity. So, kind of thinking about the commercial applications for digester facilities, I've discussed those. Also, thinking about how there's already an operation happening for methane discovery. So, I think that this could be an easy adaptation. I do plan on going back to Sniffer Robotics. I've not done that, to communicate with them and see if that's a value add service that they can offer to their clients. I encourage you to take a look at the references that are included. There's a very good video of one of our biogas facilities in Kenyonsville, North Carolina. Mustang sampling, did a video on that. It gives a really good background and understanding, so you can understand how the process works of the creation of the biogas, and then refinement and treatment for the methane that's then injected into the natural gas pipeline. Got a video and a web link for Sniffer Robotics. I encourage you to look at that video as well, understand more about GNSS opportunities and way this could be enhanced, and also what they're doing relative to thermal imaging, and also looking for methane leaks. The dairy that I'm showing on the screen is from Chesapeake Utilities Corporation. That's Full Circle Dairy in Florida. And then the Kavanaugh Solutions website that you can take a look at also for opportunities there to learn more about biogas and the way that this technology might be able to be implemented. Happy to answer any questions. My email was at the first slide. Do page back to that, or you're welcome to also reach out by cell. Thank you so much.